to see a problem illustrating an inverse Z transform. So the heading is this: H of Z is nothing but a Z transform of impulse response of a system is given as Z upon Z minus 1 by 4, Z plus 1 by 4, Z minus 1 by 2. So you have to get all possible ROCs. And we have to get inverse Z transform of H of Z for all possible ROCs. See, mentioning the ROC in inverse Z transform is very much important, because we have seen whenever I have a signal a raised to n u of n, I know straight away the Z transform is 1 upon 1 minus a Z inverse with ROC mod Z greater than a. And for minus a raised to n u of minus n minus 1, again I am getting a Z transform absolutely same, 1 upon 1 minus a Z inverse, but the ROC is mod Z less than a. So if you see over here, the right hand side is same. That means while taking the inverse Z transform, I will have only one signal, but I could get two answers, and answers depend upon the ROCs. Hence, in inverse Z transform, along with the H of Z, ROC need to be mentioned, or whatever possible ROC we will get, we need to figure out Z inverse Z transform for all the possible ROCs if ROCs are not mentioned. So let's check. So for inverse Z transform, we know for a linear factor we always take H of Z by Z, which is nothing but 1 upon Z minus 1 by 4, Z plus 1 by 4, Z minus 1 by 2. And we'll do the partial fraction of this. So I'll take this out. We'll get a upon Z minus 1 by 4 plus b upon Z plus 1 by 4 plus c upon Z minus 1 by 2. So a we can obtain from this for Z equal to 1 by 4, which is nothing but 1 upon 1 by 4 plus 1 by 4, 1 by 4 minus 1 by 2, which is nothing but 1 upon 1 by 2 multiplied by minus 1 by 4. So in the end I will get a as minus 8. Similarly, b is nothing but 1 upon Z minus 1 by 4, Z minus 1 by 2 have to be solved at Z equal to minus 1 by 4 to get 1 upon minus 1 by 4 minus 1 by 4 minus 1 by 4 minus 1 by 2. minus 1 by 4 minus 1 by 4 minus 1 by 4 minus 1 by 2. So this will be 1 upon 1 by 4 minus 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 minus half multiplied by, if we solve this, it will be minus 2 minus 4, that will be minus 6 by 8, so it's a minus 3 by 4. So in the end this will be 8 by 3. C, once again 1 upon z minus 1 by 4, z plus 1 by 4 have to be solved at z equal to half. So 1 upon half minus 1 by 4 into half plus 1 by 4. So this will be 1 upon 1 by 4 into, if we solve this, we will get here 3 by 4, and simplification will be 16 by 3. So what we will get here, h of z by z is nothing but a we get as minus 8, so it's a minus 8 upon z minus 1 by 4, b we get as 8 by 3 upon z plus 1 by 4, and c we obtain as 16 by 3 upon z minus 1 by 2. Now h of z will get as minus 8 into z upon z minus 1 by 4 plus 8 by 3 into z upon z plus 1 by 4, and finally 16 by 3 into z upon z minus 1 by 2. So once again, if we adjust the z, we'll get here minus 8 into 1 upon 1 minus 1 by 4 z inverse plus 8 by 3 into 1 upon 1 plus 1 by 4 z inverse plus 16 by 3 into 1 upon 1 minus 1 by 2 z inverse. Now all this nothing but a raised to n u of n, provided we need to find out now what ROC will give you what answer. For that purpose we need to have a pole 0 plot. So let's have a pole 0 plot. So 3 poles are over here, one at z equal to 1 by 4, second at z equal to minus 1 by 4, and third z equal to 1 by 2. If you see properly, how we are going to have a pole 0 plot? So the first at z equal to 1 by 4, so somewhere here we will have a pole. Second, z equal to minus 1 by 4, somewhere here, and third at z equal to 1 by 2, so somewhere here. So randomly I have drawn. Thing is that while finding the ROC, we will have these two poles on the same circle, because it is a circle and circle will never have a radius negative. So whether it is a positive pole or a negative pole, it will be taken care by this circle over here. So mod z equal to 1 by 4 cover these two poles, and one more circle we'll have for this, which is nothing but mod z equal to 1 by 2. So though there are 3 poles, but while selecting the ROC, we'll have effectively only these 2 poles, rather these 2 circles, and we'll have 3 possible ROCs over here. So based on that, we will have 3 answers. So let's find out the answer for the first ROCs. So what I will do, I will select the ROC that is inside the innermost circle. So let me write the first ROC. So I say first ROC is mod z has to be less than 1 by 4. So let me draw the ROC first. So this is mod z equal to 1 by 2, and this is mod z equal to 1 by 4. I said it is inside the innermost, so I'm talking about this region. So if it is inside the circle z mod z equal to 1 by 4, obviously it is inside the circle mod z equal to 1 by 2 as well. So in the end, I will get h of n as -8, and over here it's 1 upon 1 minus 1 by 4 z inverse will be minus 1 by 4 raised to n u of minus n minus 1. Then for second it is plus 8 by 3 inside bracket. We need to adjust the minus term over here. It's minus, and remember it is minus 1 by 4 raised to n. U of minus n minus 1, and finally plus 16 by 3. Here it is minus 1 by 2 raised to n u of minus n minus 1. So a small simplification will give you a final answer as 8 1 by 4 raised to n minus 8 by 3 minus 1 by 4 raised to n minus 16 by 3 1 by 2 raised to n whole multiplied by u of minus n minus 1. So this will be the answer because of this first ROC. Let's go for the second ROC. Now we'll do one thing. We'll consider the ROC outside the outermost. So let me draw. I said outside the outermost, that means the circle will be greater than the radius 1 by 2. So let's draw it. Here it's a mod z equal to 1 by 2, mod z equal to 1 by 4. We are saying it's outside the outermost. So the ROC that I am talking is this ROC. So since it is outside the mod z equal to 1 by 2, obviously it is outside the smaller circle. So we'll get h of n as the h of z will have this value So whenever we are outside the circle, it will have the same magnitude without any change in the sign. A raised to n, in this case is the 1 by 4 raised to n u of n. Second, plus 8 by 3 minus 1 by 4 raised to n u of n, and finally plus 16 by 3 1 by 2 raised to n u of n. Simplification will give you a final answer h of n as minus 8 1 by 4 raised to n plus 8 by 3 minus 1 by 4 raised to n plus 16 by 3 1 by 2 raised to n whole multiplied by u of n. So this is the inverse Z transform we'll get for second ROC. Let's check out for the third ROC. Now the ROC is between these two circles. So mod Z is greater than 1 by 4 but less than 1 by 2. So it's an annular ring like structure between two circles like this. Mod Z equal to 1 by 2. Here mod Z equal to 1 by 4. In between the two circular region will have the ROC. Now if you see properly, for the outer circle it is inside, but for inner circle it is outside. So what I will do, I will split this condition into two. What I said, for a 1 by 4 radius circle it is exterior, and for 1 by 2 radius circle it is interior. So here for the exterior we will have the term u of n, and for interior we will have a term u of minus n minus 1. So if you use this, we will get h of n as, we need to check h of z first. So h of z is like this. 1 by 4 terms are present here, first two terms, and third is 1 by 2 terms. So h of n will be minus 8 in bracket 1 by 4 raised to n u of n. Second term is also associated with the 1 by 4 radius circle. So it is 8 by 3 bracket minus 1 by 4 raised to n u of n. But the third term is associated with the radius 1 by 2 circle, and for that it is inside. So we need to adjust the minus sign, and it will be u of minus n minus 1. So if we simplify this, in the end we will get h of n as minus 8 into 1 by 4 raised to n plus 8 by 3 into minus 1 by 4 raised to n whole multiplied by u of n minus 16 by 3, 1 by 2 raised to n, u of minus n minus 1.